Well, hi everyone. Thanks again for having me today. It's good to be with you all, and it was great to see Sophia's work. Really cool stuff. Our lab is titled Generative Design at Hogwarts, Using Tech Instead of Magic, which is a fun topic. We enjoyed it as well. So my name, let's see here. There we go. My name is Alex Nelson, or Alexandra, either is fine. I am part of a design technology team at Perkins Eastman. I work as a design technology specialist. And today I'm going to go over briefly RAU sessions that will be available next week. And this is Jacob Small. Sadly, he couldn't be here today with us. He's mostly the brains behind all of this. He's really a great guy. And he's a designated support specialist at Autodesk and was kind enough to ask me to join him in this effort. So our topic really, we have 3 sessions that we go over, but we also go over some of the fundamentals for generative design and really try to outline how the magic works, going off the fun kind of Harry Potter theme. This diagram shows the generative design process and how it works. So you can imagine the Revit data goes into Dynamo for Revit. The resulting graph is built and packed into a new Dynamo file, which is then sent to Generative Design, and then eventually is sent back into Revit. That's kind of just the typical workflow for Generative Design. How this magic works is that basically Generative Design effectively takes the Dynamo file that it was sent and a series of input values and sends them to a headless version of Dynamo Core, which we all know of as like a Dynamo sandbox, for example. And this will happen 6 times concurrently on every study type. So 6 Dynamo sessions will be open at one time with data flowing from Generative Design to each and then from each back to Generative Design. So the evolutionary solver knows how to explore the space. And once the study has this data, the user interface allows us to then pick a given option. So you can imagine that selection being highlighted there at the bottom where there's 4 to 16, 12. These are some parameters that are part of the selection set. So once this selected data is sent back to Dynamo, you can make that selection, it goes to Dynamo, and then from Dynamo, it goes back into Revit to give you something in your kind of 3D model. So in a standard graph, you can imagine we're gathering data, gathering necessary inputs. We're then calculating the kind of data, and we want to make some informed decisions for what we're going to be doing. We then record these decisions, and we have an output, right? That's just the typical standard workflow. But now if we're thinking about generative design, we're actually gathering data first in generative design, but that static input for the study needs to be saved into the Dynamo file. This is where we use the remember node for generative design, and it's crucial to this workflow and kind of how that comes in to preserve it for generative design. It prevents the need to open the Revit file again in order to access that data that's been gathered. We also need to basically vary our inputs. So these need to be marked as an is input and given unique names to work in generative design. From there, we have our calculation bit. This could be a place where we make a number or place an instance, but each time the variable input changes, we need to get different results. We then need to evaluate the outcome of the calculation, measure the distance from instance 1, 2, 3, for an example, and this evaluation needs to be set as an output. And basically once we then get our output, we have our selection made, and we go back into Dynamo and use our data gate to then pass through this geometry and this selection, and then we record it again to our 3D model. This is kind of how that data gate works. It prevents the nodes which follow them from executing on our first pass when we're taking it to generative design by passing a single null value instead of the data set, and it prevents content from being recorded. But it does introduce a warning. This means you have to plan on reviewing the warnings actively. One of the important items we discuss in our lab as well is dictionaries and how useful and necessary they are for generative design explorations. They're much faster to compute. They make data easier for us to understand and save time like crazy. In this chart, we're just showing our typical process for bringing our data sets, often from Excel, immediately into a dictionary. This happens at the beginning of our script and makes accessing and adding data extremely easy and efficient. Getting used to using them on complex data sets for generative design is going to be really helpful. Another important item we discussed is just the overall generative design user interface. We've color-coded it here to outline what each section does. So the study selection in orange is where you pick which study you actually want to review. You can also pause, resume studies in this area. The results and configuration in green is where the results of the selected study and view configuration are set. Then you have the grid or list view section in blue, which allows you to toggle between the grid of geometry thumbnails or the results list. The charts view in green allows you to toggle between scatter plot and parallel coordinates for a given study. It enables and disables filters as desired. You have a few different ways to view that there. You have the scatter plot, which adjusts the X and Y axis, size, and color data drivers. You also have a parallel coordinates adjustment where you can sort and order some of these things. And you can hide these docs and resize windows to make more room for them if they get kind of crowded. You also have a details view in purple, which is basically detailed information about the study with a larger geometry preview. Cycle between results is needed. And lastly, the actions bar in red creates a new study, reviews the status of a study that is being reviewed, and opens results in Dynamo. On the bottom right is where you actually select to open in Dynamo. So if you want to then make your selection, you've got that there on the right-hand panel. It then triggers to open it in Dynamo, where you can later push it back to Revit or to another application. We will be talking a lot about permutations and how they can be applied in a useful method for offering slight variation as you're looking to optimize towards a solution in generative design. So with a list of something like ABC, which we are looking at here, you can have ABC, ACB, BAC, etc. This is a factorial design space. That's what's nice about permutations. It's an ordered system, so the digits are swapping in a particular order. And we have 3 sessions during our lab. Each of our sessions uses a different Autodesk application and shows how to access Dynamo and generative design from each of these. The first session looks at generative design in Revit. We go through how to optimize seating in the Potions classroom, and this is what our data set kind of looks like before we start. So you have a model of the classroom with a placeholder for each student, and a spreadsheet that shows information about the student, who they should avoid, who they must be separated from, and what they need to be safe in the classroom. Next, we have a landscape in Civil 3D that we use features from to make decisions on where to locate the Quidditch World Cup Stadium. So this is just taking a site, and thanks to Timothy Logan for the excellent ELK package, which we use to assemble the context design. And this allows you to kind of make informed decisions in a site about where to place the Quidditch World Cup. And lastly, we have a model of Hogwarts Castle, which is pretty fun, and the grounds surrounding it. So this shows a site, and we basically take a 2D site and we look to best lay out creatures on that site. These creatures have requirements similar to our classroom example. You can see in the Excel file here, we look at creatures they need to avoid, how far they can be from the castle, how dangerous they are. All of these things determine what's really required and how to best place them around the Hogwarts castle. And for all of these sessions, we will be walking through our Dynamo scripts. We will take a look at our generative design outputs and how we make our selection. And lastly, we will show how to push the selection back into your models. And of course, we will follow each of these with notes and reviews for how to kind of, what are the big takeaways? Because each of these studies is very different in their own way, and there's a lot we learn from them. So we want to kind of go over that with everyone. And it's also it's just a fun session, I think, and I hope you're able to join Jacob and I as we present this in full next week. Just as something else to offer here, we have some links that we're providing everyone with. Most of these, a lot of people on the call probably already have access to and are using, but I want to throw these out in case you don't already use them. Of course, the Dynamo resources, but also the generative design resources that are really useful from Autodesk and some others. So the primer, of course, for generative design is really useful, along with some of these other links. So feel free to take a look. But that's all I got for you today. Thank you, guys.
That was fantastic. Thank you so much, Alexandra. And it looks like John Newbegin already stole my question. Do you share the Hogwarts castle model anywhere?
I don't see why we couldn't. Yeah, I'll talk to Jacob. I know we share our scripts, and I believe we share the models as well. So yes, I think
do you know how that was created? Was it like a reality capture of like some sort of other model, like maybe at the Universal Studios or something? I don't even know where you would get a 3D model. The Lego castle, right? I could do a reality capture of my Lego castle.
That's true. That's true. I don't know how it was originally created, but what we did is we found a model of it that somebody had worked on in another application, and we rebuilt it in Format, which it's a little bit time consuming, but it was great. I mean, especially with Format being a new application, it was fun to kind of dive into it and remodel some of this stuff. So it also helped because if we used the other model that we originally had, it was really heavy. So in order to really make use of, again, generative design, needing to optimize your workflow, you've got to reduce everything, including the model sizes, things like that. You just want to simplify it. So that's kind of what we did there.
That would be something fun to crowdsource, right? Just like open that on BIM 360 for everybody to go in and model. I would partake. I don't know about everybody else.
Yeah, it's pretty fun.